Alright guys, so I'm redoing the video from class because there's no sound. So I'm going to walk through pretty much everything we did in class, starting off with our warm-up. I asked for students to work together and find the velocity and acceleration functions, so here we go. Starting off, the velocity, I would be doing a quotient rule, so the derivative of the high is 4, the derivative of the low is -1. So, low, d of high minus high, d of low, all over low squared. So we get, oopsie, that happens a lot, sorry. So we get, let's see, things that I want to do first. I'm going to turn this to a plus by multiplying those negatives together. I'm distributing the negative to that term. Remember, we don't do it to all. And then I'm going to multiply out. I get 4 times, oh Lord, sorry, 4 times 3, which gives me 12, minus 4t, plus 4t, all over 3 minus t squared. So we know that we get 12 over 3 minus t squared. So that's my velocity function. And the next thing I'm going to do is ask for acceleration. Problem is, for acceleration, I'm going to need to take this guy and use it to find the derivative. So there he is. This is my velocity. So to find the acceleration, I would take its derivative, but what you guys don't realize is because of the square, you have to simplify it. You cannot do a power rule, and the reason is because inside it's a function. It's not just plain x. So there we go. So I have decided to do quotient rule. That's the derivative of the top. The bottom's derivative I'll do by product rule. So leave the first one alone, multiply by the derivative of the second, plus leave the second one alone, multiply by the derivative of the first. I'll actually simplify this, and we get -3 plus t minus 3 plus t. You get 2t minus 6. Alright, so now I'm going to actually do my acceleration, which is the derivative of velocity. Low. Actually, let me even write it as a squared. Low, d of high, minus high, d of low, all over low, and squared. So just to make sure it's clear. Now, you could have done the other option, which was to multiply this out, and if you did that, you wouldn't need a product rule anymore. Alright, so next step. Multiply by 0, so that's nothing there. We get -12. And here I'm going to actually factor out a 2. I should have said that first. So I actually get -24. And then t minus 3. And in the denominator, I get 3 minus t whole thing to the 4th power. It's 2 times 2. And then what you notice is that this piece and this piece are really close to being the same. So what I'm going to do is I'm going to keep my -24. I'm going to factor out a -1 from the t minus 3. What does that do? It makes the t negative and it makes the 3 positive. So that's what it would look like. The denominator now looks exactly like that piece of the numerator. So cancel this guy, cancel this to a 3rd power, and I get positive 24 over 3 minus t cubed. And because this is a video, I will actually do the work doing the denominator multiplied out. So v of t is equal to 12 over 3 minus t times 3 minus t. And you'll notice you'll get the same answer. So I would have 12 in the numerator. The denominator is 9 minus 6t plus t squared. The derivative of the numerator is 0. The derivative of the denominator is 2t minus 6. A of t is low. And the low, I guess most of you probably, I don't know if you did or didn't. I'm going to write the low like this. Low, that's the same thing as this term right here. It's just faster to write personally. Low, derivative of the high, minus high, derivative of the low. All over low squared. So we get pretty much the same thing I had before, so I'm going to factor out the negative again, which will make that negative 2, which would make it positive 24, and I get t minus 3, and then from there you would be able to do exactly what we did before. Okay, so I'm not going to finish that off. It looks exactly like what we did before. Second problem I gave was creating a sign chart. We start off by, I gave you v of t, oopsie, and I want the sign chart for v of t, so I should be thinking about y values. So if I'm thinking about y values, the first thing I want to do is look at when my y values, so this is the function, I want them equal to 0, they'll never be undefined, and these should actually be t's, we talked about that in class, typo. So you should have t is equal to 4, 2, and 6. Things to remember when you do your sign charts. I'm sorry, I keep moving it. When you do your sign charts, you want to make sure that you don't use negative time values. So let's say this over here had a negative 8 as one of the time values. We wouldn't write it on the sign chart, okay? So we get 2, we get 4, we get 6. Those are zeros. We have no way of being undefined. Things that are helpful. First of all, I'm just going to erase this so it's not as messy. Alright, so things that are really helpful. Number one, if you look at this term right here, it's squared. It tells us two things. It tells us, number one, that to the left of this 4 and to the right of the 4, the signs will not change. We won't know if they're positive, we won't know if they're going to be negative, but we will know that they won't change. And the other thing it tells us is, because it's squared, no matter what number I put in for x right here, the value is always going to be positive. So when you're looking at a sign chart, it won't change the signs of your sign chart at all. So you could essentially kind of disregard that factor and do your sign chart using the negative 2, the x minus 2, and the x minus 6. And that's because the x minus 2 is an odd power, and the x minus 6 is an odd power. So going through, I'm going to pick 1 right here. I'm just going to write out the sign. So negative 2, that would be negative. 1 minus 2 is negative, and then 1 minus 6 is negative, so this would be negative. 3, the negative 2 is still negative. 3 minus 2 is positive. 3 minus 6 is negative, so this is positive. 5, negative 2 is still negative. 5 minus 2 is positive. 5 minus 6 is negative, so this is still positive. Notice that's positive, positive. And then at the end, a million, negative 2 is still negative. A million would be positive. A million would be positive. Therefore, this is negative. Now that I have that, all of my answers are going to be really easy. What we focused on were the y's. So I'm actually going to write all the y's first. Why would a particle be moving forward? Because velocity is positive. Why would it be moving backwards? Because velocity is negative. Why would it be stopped? Because velocity is 0. Why would it be changing direction? Because velocity is 0 and changes sign. Alright, so forward would be 2 until 4, and then union with 4 until 6. Oh, and then backwards would be 0 until 2, union with 6 to infinity. It stopped at time equal to 2, 4, and 6. And it changes direction only at times equal to 2 and 6, not at 4 because it went positive, positive. Then I moved into notes, and we talked about speed first. So speed is the absolute value of velocity. And algebraically, so from yesterday, I didn't finish this piece. So algebraically, if you want to do speed, we would look at speed by making the sign chart or knowing the velocity and acceleration functions. If I know that they have the same sign, then I know that the particle is speeding up. If they're opposite signs or different signs, then I know that they're slowing down. Now, in class, I did a really quick demonstration of why this is true. Because I'm redoing the video, I'm not going to go through the demonstration. So, this is the problem from the other day. I'm just going to rewrite the derivative. Oh, Lord. And then I'm going to actually write out the acceleration as a result. Minus 10t plus 8. And then we actually created two sign charts. So the velocity sign chart we actually did yesterday. And that was, I believe, zeros here. I think that was 1, and that was 2. 0, 0, this was negative, this was positive, and this was positive. And I'm actually going to go through. Put my positives in. So this is the same sign chart from yesterday, hopefully. Acceleration, I'm going to make a sign chart because that's what it says up there. I'm going to do that in blue. And over here I will make the acceleration factors because I want the acceleration equal to 0 to create the sign chart, and I want it equal to undefined, but the function can't be undefined. So we get 3t, I believe it's minus 4, and then we get t minus 2. They multiply to negative or positive 8. These multiply to 3t squared. This multiplies to negative 4, and this multiplies to negative 6, giving us negative 10t. Perfect. Alright, next. My t values are 4/3 and 2. So what you're going to do, you're going to line up here with the 2 and put a 2. 4/3 is somewhere between 1 and 2, so we're just going to put 4/3 in the middle between them. And then the sign chart, I'm going to create using my knowledge of parabolas. If there's 2 zeros, the parabola would be positive, then negative, then positive. So, what I asked the class to do was at every 0, just build a line at every 0. And then now you can see from 0 to 1, since the velocity is negative and the acceleration is positive, from 0 to 1, we are slowing down. I know that because velocity is positive and acceleration is positive, from 1 to 4/3, I'm speeding up. Because velocity is positive and velocity is negative here, I know that from 4/3 to 2, we're slowing down. And because these are both positive, I now know that from 2 until infinity, I'm speeding up. Okay? Particle motion using graphs. So that was the next part of the notes. What we looked at were these questions. And what I want you to see is I'm asking the same set of questions. So your reasons will always be the same. The velocity is positive when you move forward. We move backwards when velocity is negative. It stops when velocity is 0, and it changes direction when velocity is equal to 0 and changes direction. Oh, and changes sign, I should say, not direction. So, going back, if I know I need to figure out all the signs of velocity, it should make sense that we're still going to do a sign chart. And if we're going to do a sign chart, let's see. I got velocity sign chart here, velocity sign chart here. So I know, I'm just going to put 0 here, and I'll put 0 here. This is velocity, and this will be velocity. And you're going to use your knowledge of what you learned from before. To get from position to velocity, I would take a derivative. I would take one derivative to get there, And therefore, I should be saying the word slope. Velocity to velocity means I should be saying the word y-values here. So let's go through it. I'm going to do the first one over here. The slopes are 0 at horizontal tangents. That would be here and here. So that would be 2 and 6. Slopes are undefined at corners, cusps with vertical tangents and discontinuities. I would call that a corner. And then slopes are positive when the graph increases. It's increasing here, between, it's decreasing, up, going up, so it's increasing, decreasing here. And then we end at 10. I should actually put a 10 right there for your ending. Let's see. So the second graph, we'll do an orange. I should be saying the word y-values. And I'm actually going to move this out of the way. So I should be saying the word y-values. And I'll write it along here. So, what I did in class, because this isn't the best looking graph, is I actually meant it to be on the, I meant it to be on integers, so I just had them connect that down. Alright, so y-values are 0 here and here and here. Notice I say the word y-value, not velocity. Y-values are positive in the beginning because they're above the x-axis. Y-values are negative. Y-values are positive. So now that I have that, I can physically, and for you guys, it's right above your questions anyway. For me, I'm going to move this over and paste it. So there's what I need to be able to answer the questions. So for this side, I'll do in purple to match the sign chart. So I'm greater than 0 from 0 to 2, and then 6 to 9 again. Remember we stopped at 10, so just kind of remember that as we go along. It's negative when we're 2 to 6, and then 9 to 10. And therefore, because of that, we have 2 intervals equal to 0 when time is equal to 2 and 6. And it changes direction. This is, I hate doing this, but, so it changes direction at 2, changes direction at 6, and it changes direction at 9. I know it doesn't match the definition. It's because really I could put the undefined here. It's the fact that in real life, there's no possible way for like a car or a particle or something that really exists to have an undefined velocity. So that's why in the definition I don't put the undefined. But it did change direction. Alright, so I'll logically take 9 as an argument. Alright, in orange would be the other answer. So you're going to the right from 0 until 4, and then 8 until 10. You're going backwards from 4 until 8. You're stopped at time equal to 4, 8, and 10. And then we're changing direction at time equal to 4 and at 8. And you want to make sure you understand that they're not going to always be the same answers. And then look, if you confuse these graphs and you make your sign charts incorrect, this whole entire chart will be wrong. Be careful, please. Use the word slope and y values. Alright, next. Speed graphically. So I didn't get to finish this in class, so I'll probably do one little piece tomorrow. Let's see. So the definition of speed doesn't change. It's still the absolute value. So graphically, how do you do it? You reflect negative y values, velocities, across the x-axis. Alright, so with that being said, algebraically we talked about speeding up being when the velocity and acceleration are the same sign. Graphically is going to be slightly different. Graphically is when the velocity, and I'll be honest, the reason I gave you still works, and we're going to talk about that tomorrow a little bit more in depth. But in class what I said was if velocity is moving, I did that before, away from the x-axis, then the particle's speeding up. You're slowing down if the velocity is moving away. So just kidding, towards the x-axis. And in class tomorrow, I'm going to actually show why this works and why actually this means exactly the same thing as what you're seeing there, and this means the same thing as what you're seeing there. So I'm going to make that connection tomorrow in class. So we're going to start off with, I'm going to highlight all of the times we're moving away from the x-axis in blue. So I move away here, I'm actually moving away here, and I'm actually moving away here. So those are the 3 intervals where I'm moving away. What that means is the blue is where I'm speeding up. And in pink, I'm moving towards the x-axis here, I'm moving towards the x-axis here, and in pink would be slowing down. Now, you have one other option. So there's actually a total of 3 options for this. Your other option is to physically graph the speed. And the way that we do that, I'll do it in green, would be the piece of the graph right here that's negative, because this is the velocity graph. All you're going to do is reflect this graph over the x-axis. That's this piece right here. And the rest of the graph, this, all stays the same. And I'm going to do the exact same thing. I am going to highlight when I speed up. Well, if this is the speed graph, that up is important. It means that the speed has to go up for you to be speeding up. So I'm going up there, I'm going up here, and I'm going up here. Notice that's the same 3 places that were blue before, or intervals. And I'm slowing down, going down here and here, and that actually matches the exact 2 intervals when I did it the other way, which is moving towards or away from the x-axis. So, my answers to speeding up would be the blue parts, which are, 0 to 2, union with 3 to 5, union with 9 to 10. Slowing down, in pink, I would be 2 to 3, union with 5 to 9. And what's interesting is the maximum speed, you can see it because we graphed the speed, it would be 4. What I'm going to do is erase everything. What I want you to notice is that the maximum speed does not match the maximum velocity. The maximum velocity is a height or a velocity of 2. We're getting this maximum speed from the minimum velocity. That's actually really important to understand. It's because of that absolute value. So the minimum velocity is -4. When you take its absolute value, it's bigger than 2. Alright? And I think that's everything I went through in class. Tomorrow we're going to finish up these notes, and I'm going to go back and kind of make the connection between this definition here and this definition here. We're also going to graph some speed graphs. If I asked you to graph the speed from velocity, that should be easy for you because it's absolute value. If I ask you to graph the acceleration graph, you need to use slopes. If I give you a linear graph like this, the slopes are easy. They're all constant slopes. Alright, there you go.